Have you ever built a program, you enter a bunch of data and then poof, the second you close it, it's all gone? Well, today we're going to fix that. We're going to give our Python programs a long-term memory, and we'll do it by mastering how to read from and write to files.
I mean, really think about it. Every single time you run a script, it's a completely clean slate, right? Your variables, any user input, all those calculated results, they just vanish the second the program stops. It's basically a severe case of digital amnesia. So how are we supposed to build anything truly useful if our programs can't remember a single thing from one run to the next? And this is where files come into the picture. They are the perfect solution to our program's memory problem. You see, while your program's main memory is, well, fleeting, the files on your hard drive are permanent. They're the long-term memory we need to save state, store user data, and create applications that actually remember stuff. All right, so let's jump right in with the first essential skill, writing data out of our program and locking it down in a file. This is how we teach our program to take notes, so to speak, and remember things for later.
Okay, before we even write a single line of code, there is one golden rule you've got to burn into your brain. Python's basic file operations only handle one type of data: strings. That's it. So if you've got numbers or lists or any other kind of object, you have to convert them to strings first. Now, we'll get into some fancier methods later on, but for now, just remember this. Everything is text.
The whole process is actually beautifully simple. It just breaks down into 3 logical steps. First, you open the file, which basically tells Python, hey, I'm going to write to this thing. Second, you write your string data. And third, and this is absolutely crucial, you close the file. That saves all your changes and frees up system resources. Open, write, close. It's as simple as that. So let's zoom in on that first step. We use the built-in open function. The first argument is just the file name, and the second one is the mode. That W you see there, it stands for write. This tells Python to go ahead and create the file if it doesn't exist. But, and here's a big warning, if the file does exist, this mode will completely wipe it clean and start fresh. So be careful with that one. Okay, so our program can now save information. That's awesome, but it's only half the battle, right? Now we need to learn how to read that information back in. Let's dive into how our program can finally start recalling its own memories. The reading process probably looks pretty familiar. It's a lot like writing, but with one extra, really important step. You open the file, but this time in read mode. You read the data. Then, and this is the new part, you actually use that data in your program. Print it, process it, whatever you need to do. And finally, just like before, you close the file. Okay, so here's where it gets interesting. Python actually gives you a few different tools, and you gotta pick the right one for the job. So, which one do you use? Well, let's break it down. Think of .read as your grab everything tool. It's perfect for something like a small config file where you just want to slurp the whole thing into one big string. But what if you're dealing with a massive multi-gigabyte log file? No way you're using .read for that. That's where .readline becomes your best friend. It just reads one line at a time, so you can chew through huge files without blowing up your memory. And then we have .readlines. This one is super useful because it treats the file like a list. It reads every single line and hands you back a nice clean Python list of strings, which is actually perfect for what we're about to do next. Let's make this real. Imagine using .readlines to load a whole dictionary file, one with thousands of words, into a list. Boom! In a single line of code, you've got a Python list with every word. From there, it's super easy. You just import the random module and use random.choice to pick one out. It's a perfect little example of how a simple text file can become a powerful data source for your games or applications. So we've pretty much mastered plain text. But let's be honest, plain text is flat. It doesn't really have any built-in structure. It's time to level up and check out a format that handles structured data beautifully. I'm talking about YAML. I mean, think about it. What if you need to save more than just a list of words? What if you need to save a user's entire configuration? Their username, their experience level, maybe a list of items in their inventory? A plain text file would get really messy, really fast. We need a better way. And that better way is YAML. At its heart, YAML is just a standard for something called data serialization, which is just a fancy way of saying turning complex data, like a Python dictionary, into a format that you can easily store or send somewhere else. And you gotta love the name, right? It's a recursive acronym. YAML ain't markup language. It's a classic little inside joke for us developers. So what makes YAML so great? Well, first off, it is designed from the ground up to be human-readable. It's also a superset of JSON, which means any valid JSON file is also a valid YAML file, but YAML is often just cleaner to look at. And this is huge. It supports comments with a hash symbol. That's a massive advantage over JSON for things like config files, where you want to leave notes for yourself or your team. Just remember the key rules. It's case sensitive, and you have to use spaces for indentation, not tabs.
And right here, this is the aha moment. Just look at how cleanly a Python dictionary maps to YAML. Your key value pairs are just written out, one per line. It gets rid of all those extra curly braces and quotes. What you're left with is something that is clean, intuitive, and just incredibly easy to read and edit by hand. And you know what the best part is? You don't have to figure out how to parse this stuff yourself. There's a library called PyYAML that does all the heavy lifting for you. A simple pip install is all it takes to get powerful functions that can convert Python dictionaries directly to YAML files and then back again. It's that easy. So this brings us to a really powerful real-world example. Imagine a configuration file for your app. You can store all your settings, your API keys, and even an encrypted password. YAML is the absolute perfect format for this kind of structured, human-editable configuration. Whew, we have covered a lot of ground, from simple, plain text all the way to structured YAML. But you know, the absolute best way to make these concepts really stick is to get your hands dirty. So now it's your turn to apply what you've learned. So here are a few missions for you if you choose to accept them. Try writing a program that reads a file and then writes a new one with all the lines in reverse order. Or how about one that searches a file for every line containing a specific word, like snake? What about adding line numbers to a file or taking them away? Each of these challenges is going to really solidify your understanding of file I/O. So there you have it. You now have the tools to give your programs a solid memory for both text and structured data. You've come a long, long way from that programmatic amnesia we started with. But that does leave us with one final, pretty intriguing question. What about all the data that isn't text? Images, audio files, compiled programs. How do we handle those? Well, that's a story for another time.